All right, guys, so what we're going to do now is look at related rates. So we need to know how to do implicit before we could do this. And so to review with our bell work, our implicit. Guys, how can we do that? I know one of you knows how to do it because they already told me. Anyone else? I do got to take the derivative. What's the derivative of x squared?
2x.
2x.
Sorry.
What's the derivative of y squared?
Y.
2y y prime. Remember, if we're taking the derivative of like dy dx, then that means that when we're doing it for y, we have to show that we took the derivative. And then yes, the negative 100 is 0 and 0 is 0. Okay? Once I've done that, I need to... Sorry. I had to sneeze, but it didn't happen. Don't look at me like that. What do I do next? Susanna, what do you do next? Come on, Therian. Oh, girl, come on. You're solving for y prime. How do you move over the 2x? Minus 2x. So I got 2y prime. It's equal to negative 2x. What's my last step, Mariana?
To isolate the y prime.
So, what about how to get rid of 2y?
Minus 2y.
Can't minus it because they're multiplied.
Divide.
I gotta divide it. There we go. So these cancel. And we get y prime. What happens to those 2's? Exactly. So I get negative x over y. Amazing, right? Amazing. All right. So when we're doing related rates, you guys, a lot of what we're going to be doing is working with geometry and taking those formulas and then taking the derivative of them. Juanita, do it again.
Mister, they are throwing me stuff.
Stop throwing stuff at her. Well, that's true, but girl, you're throwing it. Go pick it up.
I am the was bien.
Ridiculous. Okay.
Sí.
All right. Maria Clara, take the derivative of this surface area of a sphere. What's the derivative of A? Sorry, let me back it up. Last time we were doing dy dx. This time, if I'm taking the derivative with respect to time, it means what I'm doing for all of them is I'm finding d dt. Is A or R time? It's not a trick question. Is the area or the radius time? No. Therefore, when I take the derivative, I have to show that I did it. So the derivative of A is going to be what? A prime. And then, if I've got 4 pi r squared, what's the derivative of that? R prime. Okay? And in this case, A prime, which is the same as dA dt. Huh? Well, it's 2r prime, but 2 times 4 pi is 8 pi. Right? Luciano. Too loud, guys. Okay, so dA dt is the same as A prime, because we're showing that it's with respect to time. And what would that be? That would simply be our rate of change, or from now on known as ROC, because I'm not going to write rate of change every time. The rate of change of the area with respect to time. So if that's what A prime is, what do you think R prime is? Or dr dt? What's it going to be? Probably the rate of change of the radius with respect to time?
Of the area, what is rate of change of the area?
With respect to time. W with a line on top just means with. So instead of rate of change, I'm going to write ROC. So rate of change of radius with respect to time. Yeah? Does that kind of make sense? So whatever it is we're doing, it's always going to be the rate of change of that thing with respect to time. Okay? Matthias, what's the next one? Volume of a sphere. What would the derivative of that be with respect to time? Yep. The 3 comes down. Does it cancel with anything? Yeah, the 3 on the bottom, right? So we can say just 4 pi r squared r prime. Remember, you still have to show, like, you have to take 1 away. So instead of 3, it becomes r squared and then r prime. Now, r prime or dr dt is exactly the same thing. So you don't need to write it out again. Now, v prime or dv dt, I have a feeling you can figure out what it is. It's just going to be rock of volume, rate of change of the volume, with respect to time. All of these things are just going to be the rate of change of whatever they are with respect to time. That's what we're doing. Amazing, right? What does that next formula remind you of? Should remind you of something else that you did in geometry. Starts with a P, has to do with triangles. Close. It uses the hypotenuse. Pythagorean theorem, right? This is just a rearranged version of a squared plus b squared equals c squared. Okay? Now, guys, here's the key. C is a constant. So we're saying C is just some number. So when I take the derivative of this one, it's a prime equals 1/2 c squared minus b squared to the power of negative 1/2, because we subtract 1 from our exponent, times, what's the derivative of the inside if c is a number? What's the derivative of c squared minus b squared? The c's gone, because c is just a number, so it's 0. But what about the negative b squared? What would that become? I heard somebody say negative 2b b prime. Alejandro, I'm going to kick you guys out real soon, man. So let's clean that up a little bit, because that's honestly ugly. First thing is, if I have a 2 here and a 2 on the bottom, I can cancel them. What's left up top here is going to be negative b prime. Getting rid of the negative exponent means we can put it back on the bottom. So c squared minus b squared, all to the power of 1/2. Okay? All right, so in this case, a and b prime we haven't done before. So a prime, which would be dA dt, is just the rock of a with respect to time. So if that's the case, what would b prime be? Emiliano, if that's what a prime is, what is b prime going to be?
You're going too fast. Yes, you're going too fast and I don't understand.
No, go faster.
Yes, that rock of
Rock of a with respect to time. So what would b prime be then?
Rock of B.
The rock, the rate of change of b
Respect to time.
with respect to time. Maria Clara, are you with us still?
No.
No, we lost you?
Yes.
Oh, crap. Is that any different than normal?
Is it? Yes, sir, that is.
I'm just making a comment on your general state of lostness.
Ah, yes. So you're going.
Am I going too fast?
No. Go faster.
Yes, sir. Can I go to?
When we're done.
But that lesson is eternal, right?
Eternal. Sorry.
It's infinite, right?
No. We'll get it done.
But like with 5 minutes remaining.
The last class had more than that. So it depends on how much you guys talk. All right, so.
Go fast.
Okay, so if we're doing a cylinder, why would the radius be constant? JJ, I want you to take a look at Juanita's cup. Why do you think the volume and the height could change, but the radius wouldn't? What about the thing that's inside her cup? I'm not. Okay. Does the radius of her cup ever change? Okay, it's the same. So it's constant, like this is saying. What about the liquid inside if she's drinking it? Does the height of it change? It goes down, right? Does the volume change if the height goes down? Yes. So that could be a reason that we're doing something like this. We have a cylinder container and we have something that's filling up or emptying from it. Okay? All right. So V prime is equal to pi r squared h prime, because r is just a number. We're treating r like some number in this case. Now, V prime, because we're saying that it's just a number in this particular case. There's another one that we're going to do where it's not. Okay, and this is the same. We've done this before. What is V prime, guys?
The rock of
Rock of, what does V stand for?
V.
Volume. So it's the rate of change of the volume with respect to time. And H prime we haven't technically done before, but I think you've figured out the pattern. What is H prime? Rock of what? Height with respect to time. Amazing, right? Amazing. All right, next one. We're going to do an angle. But you love trig. Juanita, I know you love trig. Oh, slow down. All right.
Sir, until what?
All right. So now we're going to do it for an angle. All right, so I've got cosine of theta is equal to x over 15. What's the derivative of cosine? Negative sine. And then it's a chain rule, so theta times theta prime equals, the derivative of x is just x prime over 15. Right, because we're just 1 over 15 is just the coefficient. And in this particular case, theta, or d theta over dt, is simply our rate of change of theta, or our angle, with respect to time. Because we're taking the derivative with respect to time. Why do you think we'd be taking the derivative of everything with respect to time? Our angle. Yeah.
Our angle.
Yeah. Or you could say the angle. Why would we take the derivative with respect to time always? That's what I'm asking. Why? Why do you guys think? Because over time things change. It's just because over time things change. Right? You're going to drink the water that's in your thermos over time. Right? You're going to use whatever, the energy from the food that you've eaten over time. Anything that happens changes over time. All right, so this is the rock of x with respect to time. And our last one is the tricky one. All right, so let's do the volume of a cone. Hey, boys, with a cone, does the radius stay constant like it did for a cylinder? No, it's changing. So if these are both changing, what rule do I need to apply when I take the derivative? If two things are multiplied together, what rule is that? Product rule, not quotient. Quotient is when they're divided, dear. All right, so this is going to be 1/3 pi, and then take the derivative of r, so 2r prime times h, the second function, plus 1/3 pi, this time r squared, because the first function is normal, times the derivative of the second, h prime. And in this case, we've done v prime, r prime, and h prime. So we know what they all are, right? It's the rate of change of the volume, the rate of change of the radius, and the rate of change of the height with respect to time. Amazing. Are you ready to apply it? Well, that sucks for you, because we're going to. All right, so air is leaking out of an inflated balloon in the shape of a sphere at a rate of 230 pi cubic centimeters per minute. At the instant when the radius is 4, what is the rate of change of the radius? So, let's look at what we have. Is this 230 pi, is that it's a rate of change, because it tells us it's a rate. So is that v prime or r prime? Is the volume changing or the radius changing at that speed?
Radius.
Not the radius, why? It's volume because cubic centimeters, that's kind of your hint. Now the other thing is, if the air is leaking out, is that going to be positive or negative? Negative. And the radius is 4. What is the rate of change? So find r prime. Okay. What are the two variables? Radius and volume. Are any of those variables remaining constant? No. In this case, none of them are. What are the rates of change that we're given and need to find? Well, v prime they gave us. It was negative 230 pi centimeters cubed per minute. And r prime is the one I need to find, and it's going to be in centimeters per minute. Now, what equation relates all of these things together? We did it on the previous page. What is the volume of a sphere? Before the v prime, before we take the derivative. Is volume equals what on the previous page? 4 over 3 pi cubed. Squared was for the surface area. Okay? Now, the next step is just to implicitly differentiate those things. So, v prime, this is where, remember Matthias did this, the 3 came down and canceled. So it's 4 pi r squared r prime. And then I just plug in everything I know. So what was v prime again?
230 centimeters.
230 pi, but remember it was negative because it's leaking out, equals 4 pi, what was r? What did it tell us r was? 4. And then r prime is what I'm looking for, so now I just solve for r prime. So negative 230 pi equals 4 times 4 times 4 is 64 pi r prime. How would I get r prime by itself, Tomas? Divide. I already heard several of you say it, so we'll just do it. Good. All right, so the pi's cancel. And I can reduce 230 over 64. What can I reduce? Can I reduce? Are they both even? So divide them both by 2. So negative 115 over 32 centimeters per minute. Yeah? Easy. All right. Valeria, you can walk them through this since you're here distracting everybody. A rock is tossed into the lake and a circular ripple is spread out to the point from where the rock hit. The radius of the circle is moving out at a rate of 25 centimeters a second. Is that A prime or R prime?
what?
Honey, it's centimeters per second.
Mister did not hear the question.
You literally took AP Calc, Valeria.
Mister, I
Is that the radius or the area?
what?
The 25 centimeters a second.
Radius.
Honey,
Radius.
is it centimeters squared?
JJ.
JJ, you go ahead, man. Say whatever you want to her. She deserves it right now.
Mister, I don't know, get
Radius.
That's my R prime, because it tells me that the radius of the circle is moving out at a rate of that. If it's moving out, is it getting bigger or smaller?
Bigger.
Bigger, so it's positive. Determine the rate of increase of the circumference. Okay, so that means that I need to know the circumference. What is the circumference of a circle? Manolo, where are you going, buddy? Okay.
That's a very good question.
Valeria, what's the circumference of a circle?
Stop. I do not know.
Then what? How did you survive AP Calc?
Pi r squared.
Did the social studies teacher just tell you that?
I
You're-
just
Do you really think that he's going to tell you the right answer?
no.
No, of course he's not going to tell you the right answer. Why would he give you the right answer?
Let's go, Lisa.
All right, then tell me what's the circumference of a circle?
come on, be.
The whole circle, I don't know.
2 pi r.
18 plus
Valeria, I don't know how you pass this class.
Esa, vamos.
Okay, so then I need to take the derivative of this with respect to time. What's the derivative of c?
C prime.
C prime. What's the derivative of r?
R prime.
Oh, don't we love these questions that are easy like this? All right, so I'm looking for the circumference. So 2 pi, what's r prime? Valeria.
Stop.
It's the only number we gave to you, dear.
25.
25. All right, and then we put those together. So the rate that the circumference is changing is, what's 2 times 25? 50 pi, and it would be in centimeters per second. Easy enough, right?
Wait, Mister, wait.
Wait.
I'm waiting. I'm not doing anything. Oh, Valeria. Girl be crazy. Oh, well, I just said that on camera. Whoops.
Your cousin Kevin.
I just called her crazy and I realized that I'm recording the lesson and putting it on YouTube. So
Oh, that's not good.
now it will forever be on YouTube that Valeria is crazy.
No, it's the real Brad.
All right, let's do the next one. Determine the rate of increase of the area of a circle when it is 225 pi centimeters cubed. Squared, sorry. Valeria, you must know this. Valeria, don't distract those two girls. Okay, I will let you do it if you can tell me what the area of a circle is.
No, you couldn't.
225
No.
pi centimeters.
Girl, you
Let's go,
literally
mister,
said it
let's
to
go.
me.
What did you say? 2 pi r. No, it was pi r squared.
You really need to stop trusting him. He's trying to make you look silly. Pi r squared. Okay, so then I need to take the derivative, right? Matthias, what is the derivative of a? Nice. All right, a little bit harder this time. What's the derivative of r squared?
I'll square
2 R.
2,
2 R squared.
2
2 r
pi
prime.
r,
R squared.
not
Prime,
squared,
prime.
r prime. All right, here's the issue. Do I know what the radius is? I do not. I know what r prime is. I don't know what r is. But if this is my area, then can't I solve for it? Because this would be 225 pi equals pi r squared. How do I find r? Isaac, first step. What do I do? What do I divide out? Pi. We like doing that because it just went away. It's gone. Amazing. All right, and how do I get rid of the r squared? Square root. What's the square root of 225? 15. You had it there. 15. All right, so now I can plug all that in. So a prime is 2 pi. Radius is 15. R prime was 25. And so my a prime is going to be 50 500, 750. Pi. Now, if it's area, what are the units?
Square.
Centimeters squared per, what's our time unit this time? Not minutes, seconds. So the area that the circle is getting bigger at is 750 pi centimeters squared per second.
Let's keep going.
Let's keep going. Let's try it.
No, pero los practice problems son para los días virtuales.
All right, we got a ladder. I'm gonna lean my ladder up against the wall. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So, just like when we did the optimization questions, let's draw a picture first. So this is my ladder. It's 25 feet long. Let's call that C. Guys, what would the rate that the ladder is changing be? C prime. Is the ladder changing? Is the ladder changing? No, so it would be 0, right? The ladder's not getting bigger or smaller. Now it says it's being pulled away from the wall, Matthias, and that is our B prime. So we'll call that one 2. How fast is the top of the ladder moving down? So we want to know A prime. We want to know how fast is this falling down if this is coming out. So how fast is Valeria falling off her ladder? You know.
Too much.
Yeah, she did. All right. And we want to know it when the base of the ladder is 7 feet from the wall. So that would be B is 7. So if I need to work with A, I have to find A. Do I have a fancy little like triangle trick that I could use to find A?
Pitágoras.
Pythagoras. So A is equal to the square root of C squared minus B squared. Remember how we did that on the first page? JJ, do you remember that? Are you here, buddy? Are you awake? You're trying to be here? Do you guys remember that I made you write that down on the first page and we took the derivative of it? Yes. What was the derivative of it? Actually, let's not do the derivative first. Let's just work out what it is and then we'll do the derivative. Let's make it easier on ourselves. Why not? All right, what was C? No, not C prime, C. 25. What's B? B, not B prime. Valeria, did you just answer wrong again? All right. 25 squared is 625. 7 squared you guys should be able to do. What's 7 squared? 49. Valeria, what is going on, dear?
I said 49.
Oh, I thought she said 39. Oh, okay.
Matthias said 14.
Ah, it was Matthias. All right, so that means that A is going to be 576. Now, I'll be real impressed if anyone knows that one. Square root of 576? 20-something. Stop guessing, it's 24.
That's the answer.
Yeah. Well, not the answer, that's just A. That's only A. Okay. Now, what relates all those things? As we already said, Pythagoras, A squared plus B squared equals C squared. Are any of those a constant? Which one of those three is a constant, if any? Not B. B is where it's moving away from the wall.
C.
C, the ladder, right? The Valeria, you literally did this question. Yeah, dear. Yeah, you did. So we can go ahead and put that in, because if I take the derivative of it, we already know what's going to happen, right? It's going to be 0 because C prime is 0. Okay. Take the derivative. 2A prime, 2B prime equals 0. Now what do I know? A whole bunch of these things. Let's plug in what we know. A is 24. A prime is what I'm looking for. B is 7. B prime is 2. And then I just work that out and solve. Which we'll do in a second. All right, 2 times 24, 48. 2 times 2 is 4, times 7, 28. Then move it over. 48a prime is equal to negative 28. Last step. What do I divide by? 48. Kind of running out of room, so I'm going to put it over here. So a prime is equal to, what's 28 divided by 48? I can simplify that. Are they both divisible by 4? Negative 7 over 12. And my units for that one would be in feet per, are we in seconds? Yes, seconds. Amazing.
Let's keep going, Mister.
Yep, I agree.
No. Ahorita está.
Let's consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing. Doesn't matter. So this is still going to be 2. B is still going to be 7. A is still going to be 24. A prime is still going to be negative 7/12. And C prime is still going to be 0. All right. How do I find the area of a triangle? Guys, these are very basic geometric shapes.
Base.
Manolo, how do I find it? What's the area of a triangle, buddy?
Length times area times.
No, area equals.
Base por altura, ya.
Base times height. Divided.
Base times height divided by
2.
2. Or we can say 1/2 if you prefer. Is that- All right, watch. She's going to immediately get mad at that. Watch. Okay. So then I would just need to take the derivative, right? So A prime is equal to, what's the derivative of B? Because this is a product rule. So B prime times the second function H over 2 plus the first function times the derivative of the second function over 2. Can I now just plug in everything? In my particular case here, what one's H? What is H in our little diagram here?
25. 24.
24 and negative 7/12, right? So H is going to be A in our case. So A prime is going to be equal to B prime is 2. H is 24 over 2. That's 24, not plus B is H prime, negative 7 over 12, all over 2. So these 2's will cancel. I'll get 24 minus 49 over 24. Why? Because keep, change, flip, right? If I divide by 2, it's the same as multiplying by 1/2. And then somebody put that in their calculator. Somebody. Micho, you got your calculator? Oh, thank God. One person out of all of you has their calculator. How about this? Maria Clara, at least tell me what the units are if it's area. We're doing feet and seconds. Feet per
Second.
Wow. Right, good thing that wasn't for marks. 958. We'll always do 3 decimals. Amazing. I think we got one more, right? What do you mean no? We'll stop at C, dear.
Bueno, Mister, ¿verdad? Se agarra.
You can do it. All right. Find the rate at which the angle formed by the ladder and the wall. So that would be this one. is changing when the ladder is 9. So I'm changing the base to 9. I can still keep my B prime. I can still keep my ladder. I can still keep my C prime. But if B is now 9 instead of 7, can I reuse any of the stuff I calculated, or do I need to recalculate it? I'd have to Now, in this particular case, I may not need to, because if I'm doing an angle, which trig function am I going to do to relate B and C, or the opposite and the hypotenuse? SOHCAHTOA, but which one? Is it sine, cosine, or tangent? Why? Well, what's cosine stand for?
We need the opposite of the
No. So you need the opposite and the hypotenuse. So which one is that?
sine.
Sine. Mary Claire to save the day. Who would have guessed? All right. Now that means I'm also going to need to find that angle first. So let's find that angle. So sine of theta is equal to our opposite side over our hypotenuse. How do I isolate theta from there? Who remembers how to get rid of sine? We usually call it sine inverse, but sure. So sine inverse of sine of theta. If we took the sine inverse of one side, we got to take the sine inverse of the other side. Sine inverse of sine goes away. Are you talking about Epstein again for real? Ah, yeah, when we can get him to shut up about Epstein. He knows some stuff. All right, Emiliano, you're the only one apparently in this entire class with a calculator. So I want you to hit sine inverse. Did you put it away? Oh, I don't even think that calculator's not even going to work. What calculator is that? Dude, there's a reason I told you guys to have this calculator.
No one has that chemistry,
I know. That's the reason you guys keep doing so poorly. I did. I know I did, because I just had to go over this for next year, and it's still there from last year. All the required stuff where I told you you needed a binder and this calculator. Do you have inverse sine on that calculator? Sine with a little -1?
Yes. Qué pesado. No es you.
You guys are killing me.
It has the
It does have it? Mary Clara, do you have a strength?
Yes.
What is it? I can't do it. My calculator won't load. Oh well.
Terminamos. Yes, we gotta put
No, we're not. It's 21.1 degrees because I did it before. Now that we've got that, let's go back to what we had before, which is sine theta is equal opposite, which was B, over our hypotenuse, which is C. Now, are any of those constants? C is a constant. So, sine of theta is equal to B over 25. Then I just need to take the derivative. What's the derivative of sine again? Cosine. So I get cosine of theta. Theta's not time. Times. Whoa, it's lagging out. Real bad. There we go, we're back. Times theta prime. Derivative of B, B prime. Then I just plug in everything I know, you guys. So, cosine of 21.1, theta prime, B prime was 2. How do I get theta prime by itself? Susanna. If I'm multiplying by cos 21.1, what do I do? Divide. So I'm going to divide both sides. They cancel. Maybe. There we go. And so is equal to, use your calculator, the one person in the whole class that has it. 2 divided by 25. What would you guys do without him? What'd you get, man? You put it in your calculator wrong.
No.
It's also lagging again. Ah. There we go.
¿Este está bien?
Almost. 0, 8, 5, 7. It's because you multiplied by it instead of dividing. Degrees per what? Degrees per seconds. Oh, that's painful, hey?